is a fantastic question. So simple to state what fraction of the square is shaded, but challenging to actually work out the answer. And what I decided to do was put some dimensions in my square because the fraction shaded is not going to change upon changing these dimensions. So if I make this length 1 and 1, because remember, we're told that the two lines from a corner to the middle of an opposite side, so that blue dot is the midpoint, and I've got myself a 2 by 2 square. So the area of this is going to be 4. And now it's just left to working out the area of the rectangle. You can sometimes split your ultimate shape into, like your big shape, into things that are all exactly the same, but that is not at all clear here. It's not like we can create lots of little equilateral triangles to make it work. So we are going to have to try and get the dimensions of the rectangle. Some things to say is that we've got a right angle here and here and here. Now, if I label this like a green angle here and then a purple angle here, what I can actually see is that the purple angle plus the green angle, they must equal 90 because inside this triangle, it must be 180. And the consequence is that this here is also going to be green. I've got another right angle here, which means I've got another purple angle here. And I've actually got similar triangles. This question is not really about a square or a rectangle, it's about similar triangles. And when in doubt, when you see triangles in a question and you're really stuck, just think, like, can I show they're similar? So let me, first of all, just draw them so they're kind of facing the same way. Okay, so the big one here is this big one here. Therefore, it's got 2 here and 1 is its height. I can now work out using Pythagoras, and I could have done this earlier on, but it's going to be root 5, the diagonal. Brilliant. And then I need to sort of reorientate this one slightly. Kind of imagine um, turning it round and then reflecting it. So actually the purple angle is at the top. The right angle of both is at the bottom. I should have done that to start with. And green angle is here. So now I can see actually it's the hypotenuse of this triangle that's equal to 1. And then what I really want is this length here. So I'll label that one X, and that is here. Okay, so going from the small triangle to the big triangle, I'm timesing by root 5. That is going to be my length scale factor, because it's enlarged by a scale factor of root 5. So to go the other way, I'm actually dividing by root 5. And what that means is X is going to equal 2 over root 5. And I've got one dimension of my rectangle. The other dimension then is going to be, oh, well, I can find out this length is going to be 1 over root 5, and that is the same as this length here. Okay, I just drawn it on the top left because it was a little bit easier to see. So this length is 1 over root 5 as this one is as well, which means the other side of my rectangle is going to be the hypotenuse of that big triangle, root 5, minus 1 over root 5. Amazing. This becomes 5 over root 5. That's the same as root 5 minus 1 over root 5. So it's 4 over root 5. Okay, and we're nearly there. I've got 2 over root 5 as one of my dimensions. I've got 4 over root 5 as my other dimension. So multiplying these two together gives me 8 over 5. And finally, the fraction is then 8 over 5 divided by 4. I can actually just do 8 divided by 4, give me my final answer of 2/5. Wow. If you're less sure about what I just did then I could write it as 8 over 5 divided by 4 over 1, which is the same as 1 over a quarter. And you can cross cancel like this, or you can times the tops times the bottoms to give 8 over 20, and then divide through by 4. But either way, you get 2/5. That is a fantastic question. Thanks for watching, and yeah, hope you enjoyed that one.